Hello, here is my DIY voltmeter that's based around an STC89C52 microcontroller. I have a single slope analog to digital converter circuit, which the single ramp is made by a JFET constant current, which charges up capacitors to give a linear ramp. And I have a voltage comparator to measure the input voltage against the ramp, so that when the voltage equals the ramp, the STC then displays the current on the screen. Here is a quick view of the soldering on the underside of the board. I tried to make it tidy. And I have a 20 by 4 line LCD. Here is the LCD fitted. And program begins. Here I have 0 volts, and now I will attach my signal generator. With the signal generator plugged in, I can vary the voltage up to 3.3. So at 3.3 volts, at 2 volts, one half volts, one volt, here I've attached a scope to look at the ramp trigger signal and the ramp generator. Here is my oscilloscope looking at the ramp trigger signal, which is green trace channel 2 and the ramp on channel 1. If I move the voltage up towards 3.3 volts, you'll see how the ramp looks up the voltage scale. So 3.3 volts, the ramp is quite linear now. So it's 3.3 volts. It's 1.5 volts, 1 volts, and 0.1 volts. have my signal generator at 0.1 volts, displays reading half from 0.054 volts, hook up to 1 volt. So 1 volt, so what, 1.048 volts, and digital count is 1863, 64. It's really stable. Two volts. .5 volts. A to D count has just gone past the 12-bit resolution. Now tippy-toeing into the 13-bit. .3 volts. And 3.3 volts. And this is my DIY voltmeter. I think this is one of the best small projects I've done in a long time. Really stable. Got 1.4 volts, 1.5. Right. Hope you all like. And goodbye.